Hi, my name is Monica Lebodi, and for my geometry project, I researched math and art. I chose this project because I am interested in both subjects and I wanted to see how they overlapped. At first, math and art seemed to be two very different subjects that had no correlation. However, after further research, I discovered that art uses both simple math terms, such as a coordinate plane, and complex math terms, such as the golden ratio and Fibonacci sequence. First, realistic art aims to draw 3D objects on a 2D surface, which can be accomplished by imagining the surface as a coordinate plane. The artist's line of sight intersects the paper, and the artist maps each real-world point to the corresponding point on the plane. Annalisa Crandall, a professor at Franklin and Marshall College, demonstrated the importance of perspective art by drawing a cube, with front and back faces parallel to each other and the paper, and the remaining edges parallel to each other, but not the surface, so that they lie along lines that come together at a vanishing point. The location of the vanishing point determines our perspective of the scene. Phi is an irrational number that is approximately 1.618. The golden ratio is 1 to 5. The golden ratio is sometimes referred to as the divine proportion. The golden rectangle has side lengths that have the golden ratio, that is, length to width equals 1 to 5. An interesting property of the golden rectangle is that if you divide the original shape into a square and smaller rectangle, the subrectangle is also a golden rectangle. That means that this process can be continued to create an infinite amount of smaller squares and smaller golden rectangles. Continuous points on the squares lie on the logarithmic spiral, which is also known as the golden spiral. To draw a nearly perfect golden rectangle, we only need a ruler and a compass. It only takes a few steps. The first step is to draw a square, which I will label as square ABCD. The next step is to find a midpoint on any side. I'll label the midpoint as point E. The third step is to connect the midpoint to a point on the opposite side. Next, place the tip of the compass on the midpoint and set the width to match the distance between segment EC. Then, draw a large arc towards BC. Next, extend side AB to cut the arc at some point, let's say point F. Draw a line parallel to line BC, passing through point F. Then, extend side DC to meet the new line at some point, let's say point G. This is now a golden rectangle. You can verify that the ratio of the sides is very close to phi. In this example, the width is 6 centimeters and the length is about 9.7, which simplifies to 1.617, which is very close to phi. Often, there are mathematicians who claim it is impossible to use the golden ratio in art because phi has an infinite amount of digits. However, pi is also an irrational number, so this argument would be like saying there are no perfect circles in the real world. Contrary to some mathematicians' belief, it is possible to use the golden ratio in art. Here are a few examples. First, Leonardo da Vinci. Born in 1452 during the Italian Renaissance, Da Vinci was known as the Renaissance man because he was a pioneer in science, math, and art. He used the golden ratio in several of his paintings, including the Mona Lisa and the Last Supper. In the Last Supper, he used various design and architectural features that show the exact golden ratio. Also, the disciples around the table were placed in divine proportion to Jesus. Another artist who used the golden ratio in his work was Raphael, who, like Da Vinci, was born during the Italian Renaissance. Raphael was known as one of the 3 master artists of the Renaissance, accompanied by Michelangelo and Da Vinci. In Raphael's painting, School of Athens, he used the golden ratio many times, making the painting appear visually pleasing. The painting has a very intricate application of the golden ratio. In fact, the image includes a grand total of 4 golden rectangles. The third artist who used the golden ratio in his artwork was Georges Seurat. Seurat was a French painter born in 1859. He is noted for his innovative use of drawing media. He was also known to have attacked every canvas by the golden section, meaning that he used the golden ratio multiple times in almost all of his paintings. For example, in his painting Bathers at Asnières, the horizon is placed precisely at the golden section. In addition to that, the left shore is placed at the golden ratio. Another artist who used the golden ratio in his work was Piet Mondrian, a Dutch artist born in 1872. In the beginning of his career as an artist, he painted landscapes. However, he later switched to a much more abstract style. Like the previous artists, Mondrian believed that math and art are closely connected. He is most famous for his compositions that used horizontal or vertical black lines to create squares, rectangles, and even golden rectangles. He then filled in the shapes he created with one of the three primary colors, red, blue, or yellow. The last example of an artist who used the golden ratio in his artwork is Salvador Dali. He was born in Spain in 1904. In his painting, The Sacrament of the Last Supper, he followed Da Vinci's lead by positioning the table at the golden section of the height of the painting. He also painted the two disciples by Jesus' side at the golden section of the width of the painting. In addition to that, the windows in the background are formed by a large dodecahedron. Dodecahedrons consist of 12 pentagons, which show 5 relationships in their proportions. Another mathematical concept seen in art is the Fibonacci sequence, which is a sequence of numbers that follow the pattern of adding the two previous numbers, starting with 0 and 1. So therefore, the first few numbers in the sequence are 0, 1, 1, 2, 3, 5, and so on. With the Fibonacci sequence, one could create a perfect golden rectangle. One starts with a square the size of 1 and adds a congruent square next to the first, and then a square with the size of 2, and so on, continuing by adding squares with the size of the next number in the Fibonacci sequence. This is because the ratio of a number in the sequence over the previous becomes increasingly closer to 5. For example, 34 divided by 21 is 1.619, and 55 divided by 34 is 1.6176. Since the numbers in the Fibonacci sequence are closely related to 5, this creates a perfect golden rectangle. This begged the question, can mathematicians create a different sequence with the same pattern? Francois Lucas created the Lucas sequence, which had the same pattern as Fibonacci, but started with 1 and 3. So therefore, the first few numbers in the sequence are 1, 3, 4, 7, 11, and so on. Like the Fibonacci sequence, the ratio of one number in the sequence over the previous becomes increasingly closer to 5. Another concept related to the Fibonacci sequence is the Fibonacci pentagon, also known as the pentagram, which connects the Fibonacci star. The pentagram is a symmetrical 5-pointed star that fits inside a regular pentagon. We can create a perfect pentagram by using numbers of the Fibonacci sequence as the dimensions. Also, the diagonals of the pentagon form another smaller, regular pentagon with the potential for adding diagonals to be drawn. This could continue infinitely, generating the golden ratio. Since the Fibonacci sequence and the golden ratio are closely related, artists who use one usually use the other. Specifically, two artists who use the Fibonacci sequence are Leonardo da Vinci and Raphael. The first artist who uses the Fibonacci sequence in his work is Leonardo da Vinci. His piece, Vitruvian Man, proves da Vinci's interest in proportions. The body, for example, is very well proportioned. Also, the golden ratio and Fibonacci sequence are used many times throughout the painting, which makes it visually pleasing. The second artist who uses the Fibonacci sequence is Raphael. Raphael's piece, Crucifixion, connects the Fibonacci star. The Fibonacci star is what gives balance to this piece. The Fibonacci sequence is what makes his art visually pleasing. I learned a lot about math and art while researching this project. I learned that to successfully draw a 3D object, I can use a coordinate plane. I also learned some new math concepts, such as the golden ratio and the Fibonacci sequence, and I was able to see how much they are used in art. To conclude, although math and art seem to have no correlation at first, they overlap in a lot of areas. I learned that art uses both simple and complex math terms. An Italian mathematician once said, "Without mathematics, there is no art."